Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, so let's take a look at this one here again. Okay. Lose one box. Lose one box. Lose one box. Yeah. Okay. I probably would have implemented it even differently. I would have just done this one here. This one could have been added here as well. Right. We say this plus this times this. Also, yeah. Max boxes. Okay. 0 hour only, right? Yeah. Okay, so what about the refactors from Baptista? So he has 2. Author Baptista. Mm-hmm. 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 Okay. So Sky Aero is happy with this. Yeah, that's good. Let me just look over it to see if I see anything quickly. Otherwise, I will be happy with it. No. Mm-hmm. Yeah, this looks good so far. Mm-hmm. 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 Okay. Mm-hmm. Okay, that's great. Yep. Mm-hmm. 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 Okay, cool. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. I expect that this is all in order and all looking good. No? Okay. Mm-hmm. Okay. Cool. Then I'm happy with that. I will merge it, but let's fix the title. So this one affects game engine, virtual function. Add override keyword to virtual function overrides in game engine. In game engine. Mm-hmm. Save. Mm-hmm. Okay. Mm-hmm. Confirm. Okay. Mm-hmm. Here's another one for game engine. Oh, so the one we merged was not for game engine? Or was it? That's also for game engine. Hold on. So 2 for game engine? What did we just merge now? Hold on. Overrides. So this one was... Well, it's also in game engine. Include game logic. Okay, so it's in game logic, and the other one is everywhere else. Okay. I would say we simply say here Refactor in game engine 2. It override keyword to virtual function overrides in game engine 2. But let's merge it another time. One of them is enough for now. Okay, let's get back to code. So here, we need to it's a portable file name. Portable file name. Read string without null. With null. Read string with null. We do ASCII string. File name. File name, yeah. File name. Say send int file length. Data length. Data length 0. Data length. So first it reads the string, yeah. String with null. Max path. We have buffer size. Okay, then we have no, not that. We have this guy here, boof. Let's call it data. Yeah. Then we take this and put it here. Then we have read object, data length. There we go. Data length, data new. And then we need a new one. Read. Do a read bytes, yeah. Read bytes. Then we do unsigned int destlen. Let's do a size t destlen, and here we have sourcelen. Then we have destlen. Mem copy. Destlen. Len. Right, source. Then we need a readlen. Readlen min destlen sourcelen readlen is readlen plus one buffer for read strlen buffer for read room for string of len plus. This ensures that the string buffer is not shared. I think there might be a bug here that it's not reading. Maybe we need to do read string with null. Maybe we need to do +1 here. Okay. Can move this away. Okay, test source readlen. Okay, and then here we do size plus equal network reads bytes data data length buffer plus size and buffer len minus size. Okay. Do I have file name and file data? Set file data to data and data length. Okay, I think that works. Okay, great. Okay, it looks good to me. Unless, of course, there are bugs. Then we have file announce, and that one is similar. Read objects. Already player mask. Yeah. So we have this file ID and player mask. Good. Then here we do file ID and player mask. And then we do for the file name, set file ID. Okay. And set player mask. Player mask. Okay, that also works. Great. Okay, we are really making good progress here. Now we have only 2 left here. Yeah. Let's do the wrapper command first. I think that one is simpler. Wrapper commands. Read wrapper message. Yeah. There's a lot of debugging there. Okay. Okay. Okay, so it's a mix of fixed data and some other data. Yeah. Okay. So, if I'm not mistaken, then we copy this here. Yeah. Then here we do 0, 0, 0, 0, 0, 0. 3 zeros, 6 zeros. Okay, 0. Okay, great. Then we have that. Then it reads that thing. Okay. And then we take all of these here. Then we delete these guys. I wonder if we should preserve those debug logs. I don't know. Maybe, maybe not. Data length, data offset. Okay. Okay, great. So data. Okay. So do we always clamp correctly here? So slan. Yeah. Wonder if we can simplify this here a bit more. STLN. Max STLN. Max STLN. Maybe here we simply do min syslen like this. Then we can remove this here. Yeah. Here we do this. Redline. Okay, this is actually incorrect here. Readline needs to be +1. Yeah. And then we don't need this here. Right. Because it's already copying the null to. Oh no. Oh no. No. Readline. Buffer for it. With now. It needs to be like so. If I'm not mistaken. Okay. So what do we have here? Read object size, blah blah. Okay. And then data. Get the data length. Get the total data length. Total data length. Where do we get the data? Set data plus I. I see. data. Okay. Okay, that's confusing to me. That is confusing to me. What is this data thing that we pass there? Does it create a copy or what does it do? Set data. What does this do? Ah, it takes a copy. Oh, okay. Okay, that's kind of weird that this allocates in here. Delete M data. And we should take this guy. Also add it here. Okay. Okay, but then that's fine. So we just pass here buffer plus size. Here we need to pass a const. Okay. Okay. I hope this is right. And then here we do size plus equal data length. Data length. Okay. Does that make sense? Yeah. I think that makes sense. Yeah. Write bytes. Set data. Okay. Okay, great. What about the other one? There was one other that had a data file command. Set file data. Do we already call that? We do. This one already does allocate here, so we don't need to allocate here. Aha. Aha. That means we can just do data plus size here. Yeah. Okay. Mm-hmm. Nope. Then here we would do size plus equal data length. Okay, then we can remove this here. But I don't like that. It basically means that we're now reading without checks. Basically, it means we trust that this length here is correct, but it's not. I don't like that. I don't like that. What we should do is do this, remove that, and in here, we simply assign data. Right. Oh, data. Yeah. Data. Yeah. Data links. Yeah. Maybe we just say here this class takes ownership of data. Here we also do const. Data. Then how do we okay, so we don't make it const. Okay. So so I would say simply do data equals data. No additional allocation. Yeah. Data equals data. There we go. And then that will be it. Okay. Okay, then we go back to set data here. So data. Then we have data length. Oof. Data. Let's call this wrapped data. Wrapped data. Okay. We remove that. Okay. Then here we also rename this to file data. Okay, great. Okay, I think that looks good. Yeah. Okay, great. Is there any other place that calls this set file data function? Well, there is, right? Compressed buff. Okay, well that doesn't work. Buff. Okay, that actually deletes it. Okay. Okay, it's a bit shady here because we give it this data, but then we delete it here. It's not good. It would be better if we were able to use a unique pointer and then we could pass it as a ref. Yeah. The std move, I mean. Okay, we can't do that. I'm not sure. I would like to avoid the duplicate allocation because that's essentially what it would have done here, right? It creates a buffer, yeah, allocates it, then it passes the buffer here, and then in here it would have created another copy of it. Another allocation, another copy, and then it would have deleted the first copy here and kept the second copy in the file message. So that was not particularly smart. Yeah. Buff. 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 Read entire and close. Yeah. Buff. So that means here it would have leaked the data, right? Yeah, this would have leaked. Read file message. Yeah. Interesting. Yeah. File data. Yeah. Is there maybe a way? I wonder. Maybe what we can do is, while we don't have a unique PTR, we create a we create a new struct here. Struct net data sync data chunk. I don't know. Okay, and then we put a data, and that's data length. Okay, and send int. Okay, great. And then we do we initialize it with null ptr and okay. How about we do we say here data length unsigned in data length and then we do data data length say let's do data length. If data length is larger than 0, then data new unsigned bytes data length. And then we do destructor if I just delete data. Then we do we had a function unsigned bytes release returned data equals data release data equals ptr, and then where do we then reset data length? Maybe. Okay, I think that makes sense. So the idea behind this now is that on set data, instead of doing that, we now pass a net data chunk as reference data chunk. Okay. Here. Data chunk, and then we do delete data, and then here data length equals data chunk dot, how about we rename it to just length, data and length maybe just size. How about that? Size. Okay, and then we say here data length is size and data chunk dot, how about instead of data we call it ptr. Okay. Then here we should also do a ptr, null ptr. Ptr returned. Let's call it just red. And then here return red. Okay. Maybe add a bit of spacing here. Okay, great. Then here data ptr, okay. And then, so that is set data here. Then we have set file data as well. Pass the same thing here. There we go. Data chunk. And now essentially we do here data chunk dot size. And then here we should do actually call release. There we go. Dot release. There we go. Okay, fantastic. Okay. And now on all the call sides, set file data, we can now do here. So data check. So we need a here a net data chunk. Data chunk. And then we construct it with the data length. And then data chunk dot ptr. Data chunk dot size. And then here we pass the data chunk now. Now the good thing is then now basically this guy consumes our data. So after this function is done, the pointer we have is gone. Like it takes ownership of this. So it's like a cleaner way to transfer it. Typically, if we were using modern C++, then we would use a unique pointer and just pass std move it in there. Yeah. But since we don't have that, we have to do like this workaround thingy, which is also okay because now we pass like the size at the same time. So that's okay. Yeah, I think that's fine. Okay. And then we need to use the same here. So we have data chunk data length. By the way, data length data. Oh, okay. So we have data chunk. Then we do data chunk dot ptr. Data chunk dot size. Then we remove this. And we pass the data chunk here. There we go. Okay, fantastic. Read bytes. Okay, then data, set data, okay. Okay, so now we basically need to use it here as well. So we have a buff. Oh, but that won't work with this here. So we need another constructor. Char. Unsigned char. Okay. So we need another constructor on this guy, where we don't just pass the size, but we pass also the PTR. So okay, PTR, and there we go. Okay, great. Maybe we can write this a bit more compact. No need to take so much vertical space. Okay, I think that's fine. So we need a buff. I would say we do a net data chunk. We call it data chunk. And then here we pass this guy and this guy. Okay. Then here we do unsigned bytes. Maybe we should do a reinterpret cast. Okay. Okay, great. Data chunk. And then this guy will now be passed here. Or will be compressed here. Compressed. Okay. Man, this is trickier than I thought. Came here to say something similar to this. No idea why that's me. Gave it a thumbs down without explaining what is wrong with this reasoning. It would make no sense if a Pathfinder Jarman would keep shooting at an empty firebase. Just shoot the infantry regardless whether it's in the firebase or not. If there's no infantry in the firebase, no need to shoot it. Yeah. Likewise, for the Stinger side, why keep shooting at it if all dudes in the Stinger are dead? Don't shoot the Stinger indefinitely, but only shoot at the dudes once they respawn. Yeah, that would be the ideal fix, yeah. Apparently, that's me. Came up with the same idea here. Yeah, easy enough. We can use some common sense here. As Pathfinder should only ever fire upon a living infantry unit. I can agree with this, yeah. That makes sense. There are two different buildings with two different properties. Stinger respawns units automatically. That's why it always shoots at it. Firebase is different. It's loaded manually. There's no reason to standardize it too. Well, I still give it a thumbs up. Let's make it shoot. Make it shoot at infantry if it's in the building, so taking anti-firebase. So I will just have the sniper focus on it, but not shoot. Only shoot once the unit spawn garrison, therefore fixes the group selection problem. And original pose also makes the interaction more logical. Yeah. Uh-huh. Mm-hmm. 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 Okay. So I don't know why he doesn't understand why I gave this a thumbs down, because it says there are two different buildings with different properties. Stinger respawns units automatically. That's why it always shoots at it. Firebase is different and is loaded manually. There's no reason to standardize it too. I still don't agree with this. Like, if there are no soldiers in the nest and the Stinger side, then there's no reason to shoot at it, right? So this statement here, it makes no sense. Yeah. So my thumbs down remains. Yeah. Thumbs down remains. Good. Sorry about that. So, so how do we proceed with this guy here? We need we have a data chunk. Okay, great. So this is, how about we call it a raw data chunk? Yeah. Okay. And then we have a compressed data chunk here, which we create how? Compressed size, compressed buff, compressed buff. Yeah. Let's take this there. Oh boy, it's hard to read here. Yeah. Man. Compressed len. Okay, and then here we do compress len, compress size. Then here we do net data chunk, compressed data chunk, and we say compressed buff. And compressed size. And so this guy could be null now, which is fine. And then we do compressed buff. Then here we do compressed data chunk dot ptr. There we go. Then here we do dot size. Let's do it like that. Okay, and here we have a delete buff. Now we remove this here. And then len is undefined. Sanctifier. Len u. Okay. Here we have raw data chunk. Data chunk dot size. Okay. Okay, I think that works. Okay, I think that should be correct. It looks a bit unholy to read here. The fire. Yeah. I guess that's fine. We could also make it except we can alternatively we can also say that we accept taking byte here. Yeah. And then here we do a reinterpret cast unsigned byte PTR. Okay. Then we can remove this here and this here. But but it means that we'll call a different constructor, right? Yeah. Is this legal? Delete PTR. Let me ask. Given the following code, is it legal? Is it legal to delete PTR when it was passed? When it was originally passed as a byte array? Byte is char and unsigned byte is unsigned char. Yes, it is legal, provided the memory was originally allocated with neo and the element type was either char, unsigned char, or std byte. Why it works? Char, unsigned byte have special aliasing rules. Any object's representation may be accessed through them. More importantly, for deletion, then freeing it as that is well defined because char and unsigned char have no destructors. Okay. Only needs to know how many elements were allocated. Okay. Okay, that's fair. Okay, cool. I was a bit worried there for a moment whether this is undefined behavior, if this was allocated as a byte. Yeah. Okay. Cool. Okay, where are we? Here. So compressed data chunk, we pass it in there. Great. Compressed boof. Okay. As far as I'm aware, this is all well. Yeah. Good. Then I think we can comment this out here. Okay, then the next piece will be let's double check that the data chunk setup is correct. So the data chunk is now responsible for allocating and destruction, but we can call release, in which case it will transfer ownership to the caller. I will set this to null and size to 0, and then return this pointer. It will delete on the destructor. It will conditionally allocate if the size is larger than 0. Yeah. Yeah. Though I wonder, maybe it should always allocate. I mean, allocating 0 sized array is legal. We could do that. Yeah. Yeah, maybe we just put it here. Yeah. Maybe we should actually use M here. Maybe we should make these private. Make it a proper class. M size, okay. Then here we add a function unsigned int size const, and that one will return M size. PTR. Return, okay. Delete MPTR. Then here MPTR, there we go. And here M size. All right. And here size. And then we can rename this size. Maybe we need to rename like so. Okay. Maybe we should do like so it's a bit easier to read, maybe. Yeah. Okay, I think that's a bit easier to digest. Now we probably will get some compile errors, so let's take a look at that. So data chunk, how about we call it data chunk Yeah, it's called as mdata actually. Then it has the same length as size. Then let's call this here dot. Okay, data. Then we also add another function here, unsigned bytes, data. Const. Return data, mdata. And then we make a copy of it. So this one returns const. And this was not. Okay, great. Okay. Then here we pass size. And here also. And here. There. Okay, great. What else? Yeah, data, size. Data and size. Okay, great. Then we have that. And then here we do, this is the last one standing. Oof. Fix the distance calculation for the radar. A side effect seems to be that the unit under radar attack alarm fires significantly more often, in particular for supply planes, causing an overload in alarms. Interesting. How about we listen into that? Let me pause here my stormy ambience. Let's listen in.
Oh, he dodged it. That's, yeah, then it's a GG, I think. That's it. That's it, boys. I was hoping I'd survive, but I don't think I can do this. Still have a leaflet, but I'm out of money. I have no income. There's one chance that I have.
Okay, that's a huge amount of alarms, yeah. Okay, that needs fixing. Yeah, it's way too much. If you're under constant attack, then you just get spammed. It's like the money value in generals, right? When you get cash or spend cash, then you have these money ticks, and they're just ticking all the time. When you have 20 black markets, it's just like a perpetual sound, like an ambient sound that becomes. It's so bad. Okay. Let me get back my storm here, yeah. Good. Then. So this is the last one here. Let me add a comment here. Way too spammy indeed. Needs nerfing to acceptable levels. Good. So this is the last one. Game command. Let's go to NetPacket. Game command. So read game message. There we go. Let's take a look at it. Oh boy. Yep. Yep. Oh boy. It looks annoying. It does look annoying, but maybe we can figure it out. So it will be a mirror of this here. Yeah. Let's take a look at it if there's something special. So it starts with a game message type, num arguments. Yeah, okay, blah blah, unsigned bytes, archetype, and then game message argument from packet. Yeah. Okay. Uh-huh. Okay, that's annoying. I would say we start by copying this shit. Yeah. And we drop it in here and we slowly transform it to what we need. Yeah. So let me also go here and add packets. We also take this guy here. Oh boy. This. So that goes in here. Okay. Okay. Type. Switch type. Last type. Oh boy. Okay. So that's the whole thing. Maybe we can simplify this thing first. So let's copy this. So let's have a size t, size equals 0. And then we have the rear, arg rear equals that. Arg rear, write primitive, read primitive. So we would change it to read object. And then what do we pass? Value. So this guy here. And then buffer len minus size, right? So this goes here. This goes here. Here we have a little accident. Okay. Okay. Okay, so that is already sorted. That's looking good. Then we should be able to remove, hold on. There's something else here. Add argument. Aha. Aha. We also need to do that. What is message? Okay, for now, let's take this guy and we move it. So I would have liked to put it behind the switch case, but it's probably safer we put it behind each line, right? Yeah, even if that looks unholy. Yeah. Yeah. I think it would be good to put it just here. Yeah. And then here we do default skip, go to skip arguments. All right. Skip argument. And then we put that here. Now we have an unholy go to, but I think it's fine. Alternatively, we could move this into a let's keep it like that for now. Okay, so I I think I need to call my minute to continue this. Right now it's a bit chaotic. This one doesn't have fixed data. I think we can move this to the top. Why do we need this allocation here? Construct game message. I don't understand why there's an allocation there. Why is this necessary? Game command message. I don't understand. Why can't we just use the existing message that we have? What is this? Oh, we do. Right. So I think this one needs to be removed. This as well. Yeah. Data. Right. So change this to command message. Skip argument needs to go down here, by the way. Okay, then we can delete this here. Delete parser. Okay. I think we can move this up. Okay, so do it like that. Okay. There would be an option, but it would make it inconsistent with all other units that trigger alarms when attacked. Mm-hmm. 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 Okay, what do we have here? Mm-hmm. Okay. Mm-hmm. Mm-hmm. Okay. Mm-hmm. I don't see clear proof that this is a bug. Is it marked as a bug? Yeah. It's not intended by the... So then the masses in the table feel logical. You don't want it to have flying over us. Hard to say. Somewhere between bug and chunk setup. Generally, heavier objects are assigned bigger masses to physicalize differently. In generals, the mass setups are all over the place. For example, the China supply truck has mass 5 and will fly to the moon when shot with a physical weapon. physicalize appropriately. And to be assigned bigger masses. Have no system. I think the Overlord is lighter than the Humvee, right? Here Overlord has mass 50, Humvee as well. So the Overlord is lighter than the Dozer. Overlord. What else is heavier than the Dozer? The Overlord. The listening outpost somehow is heavier. Yeah. Why is the listening outpost so heavy? The listening outpost is almost twice as heavy as the Overlord tank. Why? Somewhere between buck and junk. Mm-hmm. 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 Okay. Mm-hmm. Good. Then patch distribution planning. Done. Okay. What is this? Zero label. Mm-hmm. 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 Okay. Okay, I think I will end it here. Yeah. Mm-hmm. Okay. Good. I think we came pretty far here with our NetPacket refactor. This one is the last major function, which is the most complicated of them. But we should be able to solve it in the next session. Yeah. Was there anything left over in here? Oh yeah, there's some red icons here. Yeah, set data. Okay, we can comment that out. And what do we have here? Another set data wrapper. Aha. Aha. Big packet data. Aha. Oh, that doesn't work. Oh. Oh. Ah. Hmm. Okay, I see there's a problem here. Because this now is one big buffer, which is then split here into smaller buffers. Aha. 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 Okay, but we can manually allocate new ones. Yeah. Yeah. Hmm. Mm-hmm. Mm-hmm. Okay, let's deal with this next session. Good. So basically either we allocate it here and then copy over, or we add the second function here that does what it did before. That could also be done. Yeah. Hmm. Yeah. Mm-hmm. 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 Yeah, data. How do we do it here right now? Set data, data chunk, data, read bytes. Yeah. Mm-hmm. That's, uh-huh. Mm-hmm. Mm-hmm. Yeah. Also, there's a little discrepancy here. Like, if this wouldn't read the full deal, it would still pass a full data chunk size to this guy. It's not a big problem, I would say, but just a small quirk. Okay, yeah, let's deal with this next session here. Mhm. Yeah. Mhm. 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 So it would be something like NetPacket chunk, um, big packet, uh, net data chunk, big packet, and then here it would pass data size this packet, and then memcopy big packet dot data. Mm, Yes. And dot size. Okay. And then we pass here big packets. Okay, then we can put this up here. Okay, great. Why is this a short? Why is this not an integer? What is this? I'm inclined to change this to an integer, because that seems a bit unholy. Everything is operating on integer, and then suddenly that thing is a short. That doesn't make any sense. Okay. I would say this looks okay. No? Okay. Okay. Good. I will end it here. I wish you a great day or night. Until next time. Goodbye.